This question is like the previous question, and if you haven't watched that video, that's fine. But we have a proton with an initial speed of this, and it's an electric field. Did the proton move to a region of higher or lower potential energy? So if you think about this, it's coming to rest. So we've got a proton, and he's moving in, say, this direction, and he's coming to rest. If he's coming to rest, then he's going to something. If it's stopping, what's going to oppose him? It's going to be a positive charge, right? So for him to come to rest, and if you recall, charge always flows, the positive, if this is, say, the negative side, charge always flows, or pardon me, this is, by definition, a high potential, and this is a low potential. So it's moving from low to high. Think about that, okay? That's part A. Part B says, what is the potential difference of the stop proton? So you're essentially going to use this equation, because what we know, it's W stands for work right here. And so the voltage is equal to the work divided by Q. But in the case, remember, joules are joules are joules, and we have a speed. So the work is just going to be 1/2 mv squared. I know that's the kinetic energy, but that's the work. You have to oppose that energy, and you divide by Q. Oops, that's a G. Q. So you know the mass. Actually, you may not know. You need to know the mass of a proton. So the mass of a proton, you could look it up in a book. I'll just give it to you. What is the mass of a proton? I wrote it down. The mass of a proton is, kada-boom, 1.67 times 10 to the minus 27th kilograms. So you're going to plug that mass of the proton in, so you know the charge. Watch the charge, by the way, it just says of one proton. Now, this says the charge of an electron over here, but remember, an electron has the exact same charge as a proton, but opposite. So the charge goes here, although instead of being negative, it would be positive, and then you can solve for the voltage. Now watch that. I put a capital V. This is not velocity. This is capital V volts. And what was the initial kinetic energy of the proton in electron volts? The kinetic energy is just going to be, let me say this, an electron volt is going to be energy per either proton or electron, and since we only have one proton, that's easy. If I have lots of protons, you would have to multiply by lots of protons, but in this case, we have literally one proton, right, of the individual singular proton.